Hello. Today we are going to be discussing domain, range, and more specifically end behavior. End behavior is just basically an element of the range, and I'll get to that in a second, but it's not necessarily a hard concept or anything like that. So for today I've got some examples here I'm going to go over just to kind of describe what end behavior is. Now, before I can get to end behavior, I'm going to kind of review what domain and range are. So again, domain is what's happening horizontally, or what's happening from left to right. Okay, so domain is all of your x values, basically. So these are your x values. If it's a line, something continuous, you can write it in interval notation, right? Because it would include all those decimals and fractions and stuff like that. And range is going to be what's happening vertically, or what's happening to all your y values. Okay, that is being measured by what's going from bottom to top. Okay, so looking at example number one, and this is kind of hard to see, so I'm going to zoom in here a little bit so you can see. Hey, look, it does have an arrow, right? It has an arrow at the ends. So this line, if we look at it, it's a diagonal line. As it goes this direction, it has an arrow, meaning it continues going that direction, and it will continue going that direction forever. Okay, and this arrow means it's continuing to go this direction. It will continue to go that direction forever. So when we're finding the domain, we're just basically thinking, if it continues going this way, is it going left at all? If it goes left even a little bit, and it continues going left even a little bit, it's going to end up at negative infinity on the x-axis. So this is going left a little bit, so the domain would be negative infinity to, then we look at what's happening to the right. Is it going right at all as it goes off the graph? Yeah, it's going right. So it would be negative infinity to infinity. Because if we took out all the y values, this would just be a horizontal line that would just keep going both left and right forever, right? To the negative infinity on the x and to the positive infinity on the x. We run into a similar situation with the range, right? Because as it goes down, it continues to go down forever. And as it goes up, it continues to go up forever. So range is going to be the same thing, negative infinity to infinity. And then identifying if it's a function or not. Again, if you can draw a vertical line and it only hits it once, that's a function, right? If it was something like this, where you've got draw a vertical line and it would hit it twice, that would be no fun, not a function. Okay, so function, not a function. Okay, so this one is a function. So it is fun. We'll say yes because that's what we'll do on the Canvas quiz. Okay, end behavior. You'll notice it talks about x going to negative infinity and x going to positive infinity. So what end behavior basically is an extension of the range here. And basically what it's saying is if I go to negative infinity on the x, so clear over here to like negative infinity, where would your y value be? Okay, so basically it's wanting to know what direction your y value is going as you go that way. If you go to negative infinity, where would your y value end up? So is it stopping at a number, or does your y value keep going to infinity as well? So as we go here, basically I'm going to kind of follow the graph with my finger. So as I go left, what's happening to my y value? It's going down, right? So as we go left, the y value is going down. If we go to negative infinity, like go left forever, the y value would be going down forever, right? So as x goes to negative infinity on the x-axis, the y value is also going to negative infinity on the y-axis. So it's going down forever is what it's saying. If you go left forever, you're also going down forever, which is basically the definition of a diagonal line, right? Diagonal line is going both horizontally and vertically at the same time. That's what makes it diagonal, okay? And as we go right, so to the positive infinity on the x, it wants to know what's happening to the y. So as I go right, what's happening to my y value? It's going up. So if I go forever to the right, which is what infinity is, your y value would forever go up. So it would go to positive infinity on the y-axis. Okay, so you'll notice these are just the numbers that were on the range. That's generally how it works. Is you're just figuring out which side your range is hitting. Like, are you going to negative infinity on the left or the right? Is basically all end behavior is. Okay, so you're just taking those two pieces of the range and associating which side the y values would hit that. Would they hit it on the left or the right side of your graph? Okay, let's look at another example. So this one should be a familiar looking graph to you guys at this point. This is an exponential graph, right? When we're graphing exponential equations, you got the curved lines with the horizontal asymptote, your favorite word, right? Horizontal asymptotes is a line that the y value or the line never crosses, okay? So your domain, again, looking at the x values, is it going left as it goes off the graph? Yeah, it's going left forever, so negative infinity. Is it going right? Maybe I'll write infinities. Negative infinity, okay, because that's what you'll have to put in the canvas. Is it going right as it goes off the graph? Well, yeah, slightly right. It's slightly going to the right, and that's all you need. It's a slight right. I mean, it's just a very steep line, but it is still going right as it goes off the graph. So, positive infinity. Okay. Now notice I am using interval notation. Infinities always have the parentheses. You can have brackets, but it would have to actually equal that number. Okay, so the range, so we look at the least number first. So is it going down? Yeah, it's going down forever. So it'd be negative infinity. Okay, and then as it goes up, we hit the horizontal asymptote. We hit this y value at 7 that it shouldn't ever pass, right? These are just fractions that are getting closer and closer to 7, but it's never actually going to go above 7. So it's going to top out at 7. But here's the thing, and this is one of the things that throws students off a lot with these exponential equations, these exponential graphs. It never actually hits 7, does it? It will get infinitely close to it as it goes off to infinity here, but it will never actually get to 7 or above 7, which is pretty much the definition for using a parenthesis, right, instead of a bracket. I know it's a number, but the numbers can have parentheses, right, as long as it's like an open circle. These exponential equations, this is kind of the equivalent of an open circle, okay? So you would use a parenthesis there on that number 7. And then, yes, this is a function. Draw a vertical line, it's only going to hit it once. So yes. And then end behavior. As x goes to negative infinity, what y value is it going to approach? Well, we basically have a flat line here, right? As we go to negative infinity, y value is going to get closer and closer to 7, but it's never actually going to get to 7 or go above 7. So as x goes to negative infinity, y is going to approach 7. Okay, again, that's just part of your range. And then as x goes to positive infinity, so as we go to the right, your y value is going down. Okay, so as we go to the right, to the positive infinity of the x, your y value would go to negative infinity. Okay, and that's pretty much what end behavior is. It doesn't get too much more complicated than that. Let's look at another example. This one, we've got a horizontal line right here. So let's look at this. So domain should be pretty easy. It's going left forever and it's going right forever. So your domain would be negative infinity and infinity. And I'm going to give you guys a big hint right here. If it ever asks for end behavior, your domain is going to be negative infinity, infinity, because x can't go to negative infinity if it's not part of the domain, right? And it can't go to positive infinity if it's not part of the domain. So if it's going to ask you those two things, domain should be pretty easy. Okay, and then range. Ooh, this one's going to be tricky, right? Range is your vertical aspect. This is a flat horizontal line. Is it going up at all? No. Is it going down at all? No. There's literally only one number that is on for a y value for this entire line. Okay, so you're only going to have a range of one number. It doesn't go up or down at all. So I'm going to use brackets around the number -7, and that would be my range. It is literally only -7. It is only equal to -7. There's nothing else on the range, just -7. Okay, and then the function, yes, definitely a function. Only hits it once, right? So yes. Okay, end behavior. So, students get stuck on this all the time, but it is the simplest end behavior. As x goes to -infinity, what's the y value going to? Well, y value doesn't change, right? So x goes to -infinity, y is still going to be at -7. And as x goes to +infinity, y hasn't changed at all, right? It stays at -7. So both directions, y is going to be at -7. It doesn't change. It's the same thing. Okay? I'll do one more, just to make sure we got it. So, domain and range. So another diagonal line, again, going left forever, going right forever. Domain, -infinity, and infinity. Diagonal lines will always have the same domain and range, which is to both infinities, because it's going down forever, and it's going up forever, right? -infinity to infinity. Notice there's lots of infinities, so if you're ever not sure on something, you could probably guess infinity and probably get at least half of it right. Just saying. Okay, and then is it a function or not? If I draw a vertical line, it only hits it once. So, yes, it is a function. End behavior. This is kind of the opposite of the first example I did, right? This diagonal line went up from left to right. This one goes down from left to right. So let's think about that. As x goes to -infinity, that's to the left, right? So as we go left, what's happening to my y values? Hey, look, they're going up, right? Up on the y-axis is the positive direction, right? If I go up, that's going to positive infinity on the y-axis. So as x goes to -infinity, y is actually going to positive infinity. And as we go right to the positive infinity on the x, y is going down. That's the negative direction on the y-axis, right? So that would be going to the -infinity. Again, just those two pieces of the range, just written down there. Okay? All right, that's domain and range and end behavior. So if you have any questions or concerns, let us know. We're here to help. We want to help. We just need you to ask. So I will see you guys out there.